So hello everyone, this is Jahnavi and welcome back to my YouTube channel or welcome to my YouTube channel. So as you know, today we are going to do our same chapter, number system chapter, but today we are going to do the short revision part 3. In this we are going to do the decimal expansion of our real numbers. Okay, the decimal expansion. First of all, what is an expansion means? We have to tell that what expansion it is. It is terminal, it is non-terminal, or it is repeating. We have learned that. Okay, we have also read it that what kind of it says. Okay, but today we are going to see some examples because we are going to do it in a short revision. Okay, this is a short revision, that's why we will do it as fast we can. So let us start it. So the first thing is that is your decimal expansion of the rational number. So first we will talk about the terminating. Okay, so first of all we will talk about the terminating decimal. So terminating decimal, what do you mean by that? If you are dividing any question, if you are dividing like 5 by 8, you are doing this solution and you are getting remainder as 0. If you are doing any divide and you are getting remainder as a 0, then this expansion is your terminating decimal expansion. Okay, very simple. What is terminating decimal expansion? Terminating decimal expansion are those expansion in which if we are getting 0 as a remainder, then it says that terminating decimal. Okay, easy way. This is not a tough way to explain you, it's very simple way to explain you. Now let's moving on to the next slide. What did the next slide say? It is non terminating and non repeating. Non terminating means those are not in a means non-terminating, terminating and non-terminating. This is also the rational, or this is also the example of rational number, or we can say irrational number. This is the same example. Okay, so what did terminating says? Remainder is equal to 0, but in non-terminating the remainder is not equal to 0. Okay, in non-terminating what is happened that where if you are not getting, if you are dividing any of your sum, okay, and you are getting remainder as 1 2 and so on numbers, if you are getting it except of 0, then it will be as non-terminating decimal expansion. Okay, let us see this example. In this example you are seeing this green digit, it is 10, and in the last remainder you can also see this. It means they will repeat this question again. Okay, they will repeat it again with you, so that's why it is known as non-terminating. And one more thing, that is the answer came it's as 0.142857, isn't it? It's 242851. So this is not the answer, you will also write it as bar. Okay, you will put the bar because bar is really important. Okay, just a wait. Okay, first of all you will also put the bar for that, and after putting the bar your answer will be exactly completed. Okay, what do you mean by it? 0.1428 and 57, this is your question, and you will put bar over here. If you ask me why we should put bar, okay, because it's going to repeat it. Okay, it's going to repeat it because it's saying that repeating decimal, that's fine. Okay, now let's go into the next slide. Decimal expansion of the irrational number. Okay, decimal expansion of irrational number. So what do you mean by irrational numbers? Which are not in the form of p by q. Okay, which are not in the form of p by q, exactly. So the thing is this, root 2 is given to us, okay, and our pi. But first thing, if I tell you that pi didn't have an exact value, okay, so if you ask that why they have written this decimal, if you see your teacher give you the questions in your exam, okay, and what they write in the question, that pi is equal to 3.14, or they write pi is equal to 22 by 7. Okay, they write or not? They write, isn't it? So that's why we have also written it 3.14 and so on. Okay, so it means that we don't have an exact value. Are the root 7 is this root 2 are repeating. Are you able to see that it is repeating or not? It is not repeating. Can you see the repeating digit anywhere? If there was a repeating digit, then they put the bar. They didn't put the bar, it means they don't have a repeated digit. Okay, this much clear. And also the pi, this is the value, it is also non-repeating. Let's go into the next slide. Decimal expansion of the rational number we will talk about in brief. The first step, what is it? The decimal expansion of rational numbers are either terminating or non-terminating recurring. Okay, if we have shown so many of the example of it. First example is your remainder is equal to 0 and remainder should not be equal to 0. Okay, so it is also terminating and it is also non-terminating. The second says, in the latter, either a digit or a block of digit would be recurring. Okay, if I can say that 10 digit, okay, it is as remainder, so it is, if it is digiting, if this digit is repeating, recurring means repeating, recurring means repeating. If this digit is repeating again and again, so it is as recurring digit. If or we can say that repeating. Okay, the next thing is the decimal expansion of irrational numbers are always non terminating and non-recurring. Decimal expansion of irrational number, this is also a question, my kid. This is also the question. Please listen it, that every irrational numbers, the decimal expansion of the irrational number are always non-terminating or non-recurring. Recurring means repeating. Okay, clear? This much is clear. Very simple concept it is. Next thing is operation or real rubber. Should we read it in the next video? Okay, so we will discuss this in the next video with a very detailed thing, because in this we have to read about our operations, and that we will also read about operations and the laws of exponent. Okay, so meet you in the next video. So like, subscribe and share to my YouTube channel so that you can get more updates day by day. Thank you.